My name is Jamie McCrindle, and I work for Investec Bank. I'm the head of engineering there. I enjoy JavaScript and TypeScript, and I quite like async iterators. Who here has used async iterators or generators in Anger? Okay, so I hope it's not too boring for you guys. For everyone else, let me tell you a little bit about async iterators, why you'd want to use them. So why async generators? A little bit about async iterators, which is the mechanism that lies under async generators. What to think about when you're using them. I'll show you a little bit of code, Node, and no Q&A. That's still in the slides, but no questions. You can ask me questions in the break. So just a little history of async iterators. First proposal in 2014. Babel was pretty quick off the mark. Then TypeScript, available in 2017 in Node 8. At the beginning of last year, they became part of the ECMAScript standard. And last year, around April time, they're available in Node 10. So why would you want to use them? So I guess hopefully everyone knows about generators. So this is a bit of a manufactured example, but imagine you wanted to get an infinite stream of numbers and you didn't have generators. You might write code that, well, hopefully you guys wouldn't write code that looks like that. But it is way easier to do with generators. So here we're returning a coroutine, and we can essentially for loop through the natural numbers for as long as we're interested in natural numbers, and then we can stop. This is my favorite way to answer Fibonacci as an interview question using generators. So infinite list of Fibonacci numbers here. I also really like the in-place swap over there to avoid the temporary variable. Although I wouldn't be surprised if it transpiles out. Async await is pretty cool. Pre-async await, if you wanted to do any async code and use promises, you would have to you'd have to chain together your thens. And this code's not too bad, but I tended to find as soon as you got a lot of code, you'd have to kind of thread your state through all the various callbacks, and it became a little bit more difficult to read. So I find this a little easier to read, a little bit more imperative. So we just go and fetch a result, await turning it into JSON, and then we can return the USD. I think it might be obvious by now that I work in banking. So why not both? I actually couldn't decide on an image here, so why not both generators and async await? So you get all my options. And that is a crocodile with butterflies on it. So here is live rates again, written using an async generator. It returns an infinite list or infinite sequence of live rates. So I've got a while true at the top there. But fortunately, the calling code will decide when it's tired of receiving live rates. We make a call using fetch. We get the JSON out. We return dollars. And because we want to be nice to exchange rates API.io, we then delay for 24 hours. So that was kind of how to write the async generator. In this case, it's how you'd use it. And it's a similar for loop. You've got a for await. And essentially, you'd stream your async results through this for loop. Oh yeah. So this was going to be my original example, not banking related. I don't know if anyone knows what a sleep sort is, but it's a cunning way to sort where essentially if you've got a stream of numbers and you multiply them by some constant waiting time, then as they come in, they'll come back in an order. And that's how you'd write a sleep sort using async iterators. Async generators, it's easy to mix them up. So there is an underlying mechanism behind async generators, and that's this Async Iterators interface over here. I won't spend too long on it, but essentially it's very similar to how you'd implement an iterator. And there's certain cases where using the for-await syntax won't quite work for you, and you'll need to use the underlying async iterator interface. So this is interval as an async iterator. If anybody's used Rx, it's got a method called interval, and all that does is returns a value after, or a continuous stream of values, in fact, after with a fixed delay, right? So we have the fixed delay in milliseconds right at the top. You're obliged to put the symbol.async_iterator function in there, and then we've got next is called every time you want to retrieve the next value. And we're kind of delaying with promise dial then. And we also have the option to react if something goes wrong. So for example, say somebody's wrapped this in a for-await, and an exception is thrown, you can track that in your async iterator. And at the bottom, if say somebody returns in the middle of your for loop, you can also track that. So this is both throw and return are very useful for closing off resources. So if you're pulling results from a database and you want to close the connection afterwards, you can use throw or return to kind of track the fact that you broke out of your for loop. And this is live rate, same call as we saw before, only this time written as an async iterator. I think hopefully you'd agree that this is, well, the previous example of this code was slightly easier to read. So, I've been using async iterators quite a lot. I wasn't expecting to use them as much as I have been. I really enjoy the fact that they feel a bit more imperative. And so here's how you'd use kind of a line reader in classic Node. Now, I think probably by now most people don't use streams quite like this, but if you're using a line reader from the Node standard library, you'd write code a little bit like this, and you can kind of see that you can kind of read where it's going, but I could quite easily swap those two blocks of code around, and it would still behave in the same way. So you can't rely on the sequence of your code to give you a clue as to what's going to happen in what order. Instead, you could use from line reader over here, and we'll talk a little bit about the implementation of from line reader. But this turns a line reader into a series of async promises that we can read with a for-await loop. So interestingly enough, the code for this seems really simple. Actually, I'm not going to jump to the next slide yet, but there's a whole bunch of things with just pure async iterators that make them slightly hard to use in this case. And essentially, the problem is when you turn that series of events into an async stream, your consumption model changes a little bit, right? So say for example, you have a delay while consuming. So say we had that delay for a day that we saw in the example before. Unless we've got something in from line reader to slow the underlying line reader down, you could run out of memory because it could consume all of the lines before it processes the next line. And you also have to deal with a case where, for example, you start to try and read a line, but your underlying file hasn't opened yet or your network connection hasn't been made. You can borrow, fortunately, RxJS has something to solve this problem called a subject. And so, yeah, if you're using async iterators or generators, it's useful to have a library that provides something like a subject. And what that'll do is that'll just track, it'll track kind of both sides of that. So it'll queue things up before they're read, and it'll delay a promise until some data is available. So this is the implementation of from line reader. So this is how I turn something that produces a series of events into an async iterator. I am using this magical subject library, and so essentially every time you get a line, you call on next in the subject. When it closes down, you let the subject know it's completed, and you can just return the underlying iterable from the subject. I did happen to write a library called axax, which happens to have a subject in it and a few of the other functions you'll see today. there are not that many libraries out there where people have been solving these problems for async iterators yet. But they are being used in the wild. Probably the most prominent cases, if anybody's used, now is it the client or the server, is the GraphQL client library for publish subscribe uses async iterators to get the notifications. Now, when you start using them a lot, one of the things that does happen is that you can get into situations where your stream of events gets deadlocked or stuck. And this is the simplest example I could make of that. So what you've got at the top is you've got an async generator that just never ends. And we've got a 408 over there, which essentially gets stuck waiting for that result. And this can happen in weird situations. It doesn't have to never end, but say, for example, you've got some socket that doesn't close or doesn't return data. You can have issues. And essentially, the solution to this, or a potential solution to this, is a cancellation, the ability to cancel promises or cancel async iterators, but that's still being debated on TC39. All right, let's see some code. Dark mode. Sorry if I've blinded everyone. I'll have to remember that if I present something else. Can everyone see that? Can you make code bigger? I feel like you should be able to. Okay. Hopefully everyone can read that. So at the top there, I've had to wrap everything in an async function because we don't have a wait at top level. So kind of ignore the async function run if you can, and just look at what's happening in the middle. So we've got a 408 loop. I'm just turning an array of dates with one date into actually an async generator, and that lets me put in a wait in the for loop. Right? This is not the best example, but I wanted to go for the simplest case. So if I go node simple.js. I remember that I'm not connected to the internet. That's inconvenient. What was the Wi-Fi password, anyone?
You just connect to CN guest.
Yeah, perfect. Oh no. All right. Given my VPN also has to wake up, I might avoid running the code, and I'll just show you the code. Right. So believe me when I say that. Yikes. When I make this call, it will go away to exchange rates IO and go and get me the pound-dollar exchange rate. So imagine now I had a giant file of data. So I wanted to look at historical rates over time. And I've got this huge file over here. And perhaps I want to go through that file line by line and call that same API endpoint. So I'm using that from line reader that we saw before. So you've got lines from line reader. I'm going and creating a readline library, so that just creates that underlying node streams line reader. And we can see the code remains pretty much the same. I can just iterate through that async stream of lines. And so this is pretty handy. If it's a giant file, I can just process that asynchronously as it comes in. So and I find this kind of imperative syntax, again, a lot easier to read. And then finally, I don't know if anybody's done this, I needed to do this before, but sometimes you may want to call some URL endpoint in parallel, but you don't want to hit it too hard. So perhaps you want to only hit it with 2 concurrent threads. So we've got this concurrent map over here. So same code again, only this time I've put a concurrent map in the middle of it. All that does is returns an async generator where it will run that mapping function kind of concurrently. So I have right over here said that I want a concurrency level of 2, but I could say, I'd like 10 to run in parallel. It'll then call that API asynchronously in parallel, or concurrently at least, with 10 of them concurrently, and return the same data. Although don't do this to exchange rates API.io because you probably blow them up after a while. I don't know how I'm doing for time. I feel like I rushed through that. But yeah, that's it. Thank you very much, everyone. I hope that was interesting.